Hello, good day. I am here to discuss a linear programming minimization problem. So this is the case for the company Best Milk Product Inc. Michael is the planning manager of Best Milk Product Inc. Wants to determine the supply mix that will result on the minimum cost. So let's take note that ating objective function is minimization. He was able to determine the data necessary for him to make a decision. A gallon of Alaska milk can produce 5 cases of cheese, 7 cases of butter, and 9 cases of cream, while a gallon of Nestle milk can produce 11 cases of cheese, 8 cases of butter, and 4 cases of cream. He must produce at least 110 cases of cheese. So take note, we have the words at least 112 cases of butter, and 72 cases of cream per day. Alaska milk costs $50 per gallon while Nestle milk costs $55 per gallon. How many gallons of Alaska milk and Nestle milk should he purchase per day to minimize cost? So our objective is minimization, and let's uh, generate the table 1 or the step 1, the tabular form. So first we let x cases or the number of cases per gallon of Alaska milk. So this is product 1, the Alaska milk. Then we let y as case per gallon of the Nestle milk, which is product 2. Okay, we have the row info, our outputs, and then we have the products x and y. This is in case per gallon. And then we have the sign and the right hand side values or the parameters. Okay. Uh, so pagbabasahin natin ito, sabi dito, a gallon of Alaska milk, which is X, can produce, there are 3 outputs, no? Cheese, butter, and cream. So we write for the constraint part, we have cheese, butter, and cream. So a gallon of Alaska milk X can produce 5 cases of cheese, 7 cases of butter, and 9 cases of cream. Okay? A gallon of Nestle milk, which is Y, can produce 11 cases of cheese, 8 cases of butter, and 4 cases of cream. Okay? He must produce at least. So pag nabasa natin yung at least, the sign should be greater than or equal, no? So in minimization problems, remember, one general relationship is that each functional constraints usually has at least or greater than or equal requirement in its form, pero but not limited to or if the case warrants or allows it. So, depende yung sign natin sa problem pa rin. Pero since sabi dito sa problem na to, at least, so we will use the greater than or equal sign. So, mababasa natin dito, he must produce at least 110 cases of cheese. So, greater than or equal to 110. And then, for butter, we have greater than or equal to 112 cases of butter. And for cream, we have greater than or equal to 72 cases. And then for our objective function, this is minimization, so we put min and C for cost. Malaska milk cost $50 per gallon, while Nestle milk cost $55 per gallon. Okay, that is table 1. And for step number 2, rather, is the LP model. For objective function, min C is equals to 50x plus 55y. And then subject to the following constraints, just copy the table data. For cheese, for butter, and for cream, and both products x and y is greater than or equal to 0. So it means this is for non-negativity constraints. Okay. For step 3, is the graphical and the corner point feasible solution method. Okay, we will plot first the line for the equation 1. Equation 1, excuse me. For equation 1, so this is equation 1, this is equation 2, equation 3. So when we substitute x is 0 in equation 1, y is equals to 10. When we substitute y is equals to 0, x is equals to 22. So this is the equation 1 line. Okay. For equation 2, when we substitute x is equals to 0, y is 14, when y is 0, x is 16. And for the last constraint, if x is 0, y is 18. When y is 0, x is 8. Okay, so we will now put shading on each line. Since all of them are greater than or equal, the shades or the shade will be above the line. So for line 1, shade is above the line. For the second line, the second constraint, above the line also. And then for the third equation or the third line, shading is also above the line. And since we have the non-negativity constraints, we will not consider the second, third, and fourth quadrant. We will just concentrate in this first quadrant. And then next, we will find the common shaded region for the three lines. As you can see, this is the common shaded region. Okay. So therefore, this is the what you call the feasible region. Okay, the feasible region. Now, for steps number 4, we get the vertices and its corresponding cost. Okay, So for this vertex, this is 0 and 18. We substitute 0 and 18 to the objective function. We will get $990. Okay. For this vertex, this is 2.95, sorry, 2.91 and 11.45. So substitute it to the objective function. We get 775.25. For this vertex, this is 9.50 and 5.68. We will get and for the last vertex, which is here, that is 22 and 0. That is $1,100. Since we are getting the minimum cost, so we will get the lowest value of among the answers. So the lowest value is this one. For step number 5, decision making, thus the manager or Michael should buy 2.91 gallons of Alaska milk and 11.45 gallons of Nestle milk per day at a minimum total cost of $775.25.